Hello everyone. In this video we will understand RSRP. RSRP stands for Reference Signal Received Power. As the name says, it is the received power on the reference signals. Okay. This is calculated at the UE side from the SSS signal transmitted by the G node B. As we have seen this SS burst, okay, we have PSS, SSS, PBCH and PBCH DMRS. Okay, so there are two different RSRPs. One is calculated from SSB, known as SSRSRP, basically calculated from SSS. Okay, other one is CSI RSRP, calculated from CSIRS reference signals. Okay, so this tells the received power on a particular RE. Okay, RSRP doesn't account for interference, noise or anything. Okay, it just tells what is the received power on a given RE. If it is RSRP, then what is the received power on SSS resource element. Okay, as we see, there are total 127 REs. Okay, so UE reads the received power of each RE, okay, and then average them on linear scale. Okay, so these powers are averaged on watt, okay, not in dB. Okay, so let's say the received power is x1, x2 to all the way x127. So the powers are averaged x127 by 127. Okay, this becomes my RSRP in watt. Okay, where x1, x2, xn are in watt. Okay, we later convert this into dBm. Okay, so mostly the RSRP is displayed in dBm, but it's a average on linear scale. Okay, for FR1 it is calculated, or the UE read it from UE antenna connector. Okay, normally the assumption is that in FR1 we don't combine many antenna elements. Okay, so in FR1 it's from UE antenna connector. Okay, where in FR2 we assume that there are many antennas connected, so it's a combined signal strength from all antenna element. Combined antenna strength. Okay, the range of the RSRP is from -44 dBm, is the highest, to -140 dBm. Okay, -144 is the highest. This is the highest value defined that the UE is expected to have. So normally even for UE the maximum input power that is defined is -20 dBm. Okay, so even if the UE receives -20 dBm only on SSS, okay, or let's say SSB, okay, then still the -20 is for the RSRP will be corresponding to -20 dBm is -20 minus 10 log 10 240 subcarriers, so it becomes -44 dBm. Okay, so this is the the highest power you expected to receive, and this is corresponding the highest RSRP. Okay, these screenshots I have captured from my phone. Okay, and as you see, this is the RSRP at a different instance. It also shows SINR and RSRQ that we will see in the next video. Okay, so normally if the RSRP is better than, it's more than minus 80, okay, then it's a good RSRP. Okay, if it is below 100, then it's bad, very poor RSRP. UE normally what I have observed is UE normally disconnects if the RSRP goes minus 110 or minus 115. If it is goes below that, then UE disconnects. Okay, and here also, as you see, for my phone it shows antenna maximum RSRP is minus 44 and the minimum RSRP that it can receive is minus 114. Okay, so below this it will it won't receive the signal. Okay, so this is about, so just to give a reference that what minus 44 dBm looks like in watt is minus 44 dBm is around 40 nanowatt. Okay, 40 into 10 to the power minus 9, which is nothing but 10 log 10, 40 into 10 to the power minus 9, 10 to the power minus 3, which is minus 44 dBm. Okay, this is about RSRP in 5G. Okay, in the next video we will understand RSRQ. Okay, thank you.